Hello, Math 7. We're in this lesson we're going to work on finding the volume of a sphere. I don't know who thought that was a good word to describe a ball, but sphere is the word. There we go, volume of a sphere. How do you draw a sphere? Make a perfect circle, which no one can. Make your best circle. Then find about the midpoint and do an dotted oval, kind of like when we were drawing cylinders. Find the dead center. That kind of gives its three-dimensional view. Of course, I can only give you two different things here. I can give you the radius, or I can give you the diameter. Now, what's fun about the diameter is I can keep it inside the oval. It gives the illusion of going across. That one kind of slipped out. Of course, like with almost all of our circular volume and surface area equations, we want the halfway, we want the radius, not the diameter. So if I do give you the diameter, make sure to cut it in half. It's a weird formula. It is 4/3 pi times the radius cubed. Now, the radius cubed means it's radius times radius times radius. So if the radius was, let's say, 6, it'd be 6 times 6 times 6. And you would get, that's 216. So, how would we work this problem out? Now, I gave you a radius that's divisible by 3. So if I work the entire thing out by hand, the pi just sits there. I know if the radius was 6, then that'd be 216. I'd divide by 3, because it's divided by the bottom, multiplied by the top. 216 divided by 3, it's going to be 72. Wrote that weird. And then I'd multiply by that, by the top. 72 times 4 is 288. So I get 288 times pi, 3.14. Use my wonderful calculator here. 288 times 3.14 gets me 904.32. Whatever units of measure I'd give you, and that would be cubed. Now, of course, you don't have to do it by hand. You can plug it in to the calculator and solve it that way. But not everybody has the fraction in their calculator. So I'm going to assume that all you can do is multiply, divide, add, or subtract, and just have your basic calculator skills. So we'll do it that way. So let's do another example, and then I'll give you some problems to try. Another circle, semicircle, dot in the center. Almost looks three-dimensional. Let's do a full diameter this time, from one side to the other. And let's make this a wonderful 21 centimeters. Okay, so if it's 4/3, I just realized I made this much harder than I wanted to. Pi times the radius cubed. Now the radius is 10.5 cubed. So here's how I'm going to do that on the calculator, because the order that we do this is important, I believe. So I'm going to do 4 times 3.14 times 10.1, or that's right, I'm assuming you guys don't even have a squared button, so I'll just do it all by hand. So it's going to be 4 times 3.14 times 10.5 times 10.5 times 10.5 5. And divide that all by 3 at the end, and let's see what happens. Is that the right answer? 48, 46, 59. Sounds good to me. Now, of course, there's no real good way to check these. So we're just going to assume that we're smart. And that's going to be centimeters cubed. So its volume is just using the equation. I will try not to give you numbers that are not easily divisible by 3. Although I did give you a number that was divisible by 3, didn't I? Awesome. Here, I'm going to give you 4 problems now. Let's see. I'm going to... Oh, it doesn't quite fit my video. Okay, so here's that sheet of practice problems for you. 4 spheres, actually 3 complete ones, and 1 semicircle sphere, so a semisphere, half a sphere, half a ball. A hemisphere. Ooh, look at that. That's so lovely. So pause the video, work these 4 out, and then I'll show you how to do them. So pause the video now, like right now, like, yeah. Okay, so now you're done. You've worked them all out, and we're going to check. So our formula is 4/3 of the pi's are cubed. So we've got 3 for a radius is halfway. So 4/3 times pi, 3 cubed. I know that 3 cubed is 3 times 3, which is 9, times 3, which is 27. So I've got 4/3 pi times 27. I know that 27 divided by 3 is 9, and 9 times 4 is 36 pi. Now, one of the reasons why I like to work it out by hand before I multiply by pi is, as I said on the second example, it's really hard to know if you're right unless you do this math first. So now I know I'm multiplying 36 basically by 3.14. Basically, 3 times 36 is 90 plus 18, so 108. So this should be somewhere 115, something like that. And that's why I like to work them out by hand, because that's the only way I know if I'm right. So 36 times 3.14 is 113.04. And that's going to be centimeters cubed. So as you can see, just kind of having an estimate first makes it works out so much better. This one up here, I gave you a diameter of 12, and so the radius would be 6. So 4/3 pi 6 cubed. We actually did this one already, didn't we? I already told you that 6 cubed is 216. And I'll repeat the process. 216 divided by 3, that's 7. And 2, so 72. And 4 times 72, I already told you, is 288 pi. So 3 times 288, that's going to be somewhere around 900. The way I look at it. And so we've got 288 times 3.14. And you get 904.32. And that is going to be feet cubed. Now come on over to this guy. He has a radius of 9 meters. So 4/3 times pi times 9 cubed. Now 9 times 9 is 81, and 81 times 9 is going to be 729. So I've got 4/3 times pi times 729. And I divide 729 by 3. That's going to be 24, because that's 3 days right there. And 3, so 243. Ew. Times 4. That's 800. 960. 972. Oof, that's a big one. Times pi. So this one's going to be somewhere around 28, 2900, I would imagine. Let's see what we get. 972 times 3.14. Wow, nope, all the way up over 3,000. I guess that makes sense. It's closer to 1,000. Anyways, so 3052.08 meters cubed. And now for the hemisphere, the semicircle, the semisphere. I gave you a diameter of 15, which means my radius is going to be 7.5. Ew, it's an ugly one. Okay, 4/3 pi times 7.5 cubed. I don't know 7.5 cubed off the top of my head, so let's do it. 7.5 times 7.5 times 7.5 is 421.875. That's a cool number. 421.875. Let's divide that by 3. Okay, 140.625. And then let's multiply that by 4. We get 5,625. Nope, that's 0.5 pi. Okay, so my estimate, this is going to be somewhere around the 1800s, something like that. That'd be a good estimate, right? So let's multiply that by 3.14, and I get, yeah, there we go, 1,766.25 inches cubed, and that's a full sphere. So now the final step would be to divide this by 2. What could I have done differently? I could have halved in the beginning and just did 2/3, but it doesn't really matter. So divide by 2 now, and I get my final answer, 883.125 inches, that's an M, inches cubed. All right, that's how you work out those 4 problems, and hopefully you're doing well on those. I'll give you another lesson here in a moment about finding the volume of prisms.